Right, just going to do a selection of problems from the differentiation questions, and the key thing here is you have to differentiate using the product rule, and this is a point to note, simplify your answers. So a bit of final algebra here to get the same answer as you'd expect hopefully to see here in the New Lake answer sheet. So let's start with 173, and straight away we're seeing two parts to it. So this thing here times this thing here. So and there's obviously a time. So I'm going to say let u equal the first bit here, 3x squared plus 5x, and v equals e minus 3x. And then I'm going to do the product rule underneath it here. Du by dx is 6x plus 5. dv by dx is negative 3e 3x. Now, those are skills hopefully you're just comfortable with by now, how to differentiate an exponential function. Now, the product rule says what? The way we got this set up, it's a different colored pen here, it's the diagonals. Now, it's very important that you set this working up because then it just flows nicely. So basically, let's just stop there. Let's just look at what I'm referring to. Let's go admin here. Okay, so the product rule. In essence, this one here is probably a bit more user-friendly to look at, but I like using u and v. Okay, so what have I just done? I've said, that section's u, this section here is v, and then it's u times the derivative of v plus v times the derivative of du. So in other words, that's that times that, or that plus, that. So there's two diagonals. So it's very important that you set up your working and then the rest will flow easily. Okay, so let's just put this thing over here and finish this off. So then I can with confidence just say q dash equals, does it matter which way I did them first? No, it doesn't, because you're adding these two terms. Just confirm that. That bit there plus that bit. Doesn't matter which way we present it first. But for argument's sake, that's u times dv by dx. So that's going to be this way here first. So I put brackets 3x squared plus 5x times that. I'll put I'll just put the full thing out, 3e minus 3x, and then plus bracket 6x plus 5 e negative 3x. Now, that technically is the answer, but because the question said simplify, you have to simplify. So is there a common factor? Yes, there is. The common factor is e minus 3x, bracket, what's left? Minus 3, put that in the front. This thing, 3x squared plus 5x, close it off. What's left? Plus 6x plus 5. Okay, in fact, I'll put square brackets there to indicate inside there. Now, do we stop there? I'm just going to cheat here very quickly. And by cheating, let's see how much detail. 173. Nope, that is not the same answer. So what we need to do now is inside here, do some work. So that times that is negative 9x squared. That times that is minus 15x. That times that, it's just 6x, isn't it? Okay, so simplifying inside there. What do we got? These two terms simplify. So we've got e negative 3x bracket minus 9x squared. What's that? Minus 9x plus 5. And let's see if that is the answer to 173. And thank goodness it is. There it is there. Minus 9x squared minus 9x plus 5. So there you have it. Solid merit, that skill set there. Right, this one here, slightly more complicated because we've got this bit here. Looks a bit nasty. So if you really rewrite that, that's natural log of x to the power of a half. So this is going to be your u, and we'll make this here the v. So let u equal 2x plus 1. du by dx is 2. v equals natural log x half dv by dx, sorry, is, now this is getting complicated. So over here, we're going to have to do a bit of chain rule action on this side, okay? So in fact, just put a dotted line here. Let's just pretend this is a separate thing. I'm going to call this y equals natural log x over half. So inside the square, the dotted box here is a completely different sort of bit of calculus going on. So here I'm going to use my go-to, which is always u, that u equals x to the power of a half. Therefore, y equals natural log of u. Du by dx is a half x minus a half. Half minus 1 gives you negative a half. Dy by du is 1 over u. Therefore, y dash is that thing. Now this is getting complicated. Okay, this side here, 1 over u. Whoops, let's just bring this picture. What's u? U is that thing. So that is 1 over x to the power of a half. So we're looking at 1 half. I'm going to drop that down times, oh my goodness. Let's just make this a bit larger so we can see it. So I got y dashed equals a half. This bit here came to be 1 over x the half times this bit here. What are you seeing? That times that gives, now what's that? That's like saying x a half times x to the half, which is x to the power of 1. So all that gave you this. That's interesting. So I'm just going to, that there went in here, 1 over 2x. Okay, so now we do the product rule. That times that plus that times that. So p dash equals 2x plus 1 times that, which is over 2x, plus that times that, 2 natural log x to the power of a half. I don't think we can simplify that. Okay, so let's have a quick stab at this, and let's see if 180. Okay, 180. So they've got, right, so that top expression there is what I've got. 2 natural log, okay, this thing here, you can, what the heck? So we can say, that's like saying 2 natural log square root x. So that's that bit there, plus 2x plus 1 over 2x. No need for the brackets there. Okay, now what have they done here? If you, for some reason, they've shown an extra line of working here. What they've done is bizarre. Oh, I see what they've done. That's clever. That's very clever. Okay, can you spot that? This is using some log rules. Oh, okay, next level. So if we just jumped up to here, what they've just done is they've used this rule here. Okay, let's see what they've done. So basically, if we were to look at this expression here, we can rewrite that as natural log square root x. And what happens to that 2? The 2 can come up here. So what's that like saying? Natural log x to the power of a half squared. What happens? That gives you natural log x. That's a more elegant answer, and well done if you spotted that. To be honest, I did not until I saw the answers there. So if you've got a coefficient in front of a natural log or a log function, you can, by what rule? By which way? This way here. By things you hopefully were comfortable with, you learned in the year 12 algebra course, so we could apply that rule there. Whoa, okay, that is looking like a lot of algebra there. Fantastic. Right, let's do one more because I'm doing 3 per bracket here. This does look pretty nasty. Again, we've got this dude here. Now, in fact, let's just cheat here slightly. I'm going to borrow from obviously set that one there is the same thing here. So we're going to, all the hard work we did for 180, we're going to use in here. So we're going to call this one U, call this one V, and so let U equal E 2x minus 1, and let V equal natural log square root x. And look at this very quickly. dv by dx came to be, what did we do over here? dv by is 1 over 2x. So I'm just going to put there straight away. Too easy, 1 over 2x. Now here's a bit more work. we're going to have to do here. In fact, let's just take this and change pen. Let's go to red pen, and let's just do this over here. I'm going to say y equals e2x minus 1. Let u equal 2x minus 1. Therefore, y equals e to the power of u. Du by dx is 2. dy by du equals eu. Therefore, y dashed is 2 times that, 2e 2x minus 1. Okay, now you could have just, after practice, seen that and straight away written that down. Good for you. But what I've just illustrated here is, it's fail safe, just a side section piece of paper here. Change your pen. Obviously not supposed to use red in the assessment, but use, I don't know, a different color, black or blue. And then, prove to yourself, yep, that's what it should be. But if you're getting super confident with your chain rule and you can do it in your head, well, good on you. So straight away, du by dx is, we've established that, 2e 2x minus 1. And what do? We cross multiply. Okay, so that one down there. So we've got f dashed is that times that, e 2x minus 1 over 2x plus something horrific, 2e 2x, 2x here minus 1, that times natural log square root x. And what are we saying about this thing here? We said basically that's like saying natural log x to the power of a half. Actually, there's no change. That 2, you could argue, comes in there. Anyway, there is a common factor of this thing here, e. So let's take that out. E 2x minus 1. What's left? 1 over 2x plus this thing here. What did we learn from the previous example? 2 natural log x to the power of the half. That can be like saying natural log x. So plus natural log x. And that could be the answer. Okay, let's just check that. Sometimes they don't like having a fraction in a term. I'm guessing they probably won't see that. Let's have a look here. Page 185. Okay, so guess what? We did that one there. Okay, what have they done here? No, they haven't taken out the common factor of, you could argue with our result is slightly better, but it's exactly the same thing. Technically, you could do some more fluffing around in here. You could turn that into a fraction, and you could say this, it's 1 plus 2x natural log x over 2x. So that would be another variation, but all still the same thing. Well done. So that is 3 problems there, and here, look at the calculus we're starting to do now. There's lots of algebra here, and just practice and get really good at the product rule is a key requirement in the differentiation paper.